Welcome to Lesson 3 of NOS 120, where we're locking in on network security in Linux. Whether you're working with servers, routers, or firewalls, Linux is at the core of many cybersecurity operations. This lesson will give you a solid grip on how to protect Linux systems from real-world network threats. Think segmentation, VPNs, wireless risks, and proxy configurations. Let's dive in and break it all down in a way that makes sense and gives you actionable skills. Here's what we're setting out to accomplish. First, we'll explore how breaking a network into segments using tools like IP tables and firewall helps stop attacks from spreading. Next, we'll dive into VPNs, those secure tunnels that keep your data hidden even over public Wi-Fi. And finally, we'll check out common security risks tied to wireless networks and proxies, and we'll go over tools like Tor, Nginx, and Squid that can make your network far more private and resilient to attacks. Network segmentation is one of those tried-and-true cybersecurity tactics that never goes out of style. By splitting up your network into smaller chunks or segments, you're reducing the blast radius if something goes wrong. If a hacker breaks into one segment, they can't just waltz across your whole system. It's a smart way to enforce least privilege, only giving access where it's needed, and it's a cornerstone of defense in depth, which is all about layering your security so if one thing fails, something else catches it. In Linux, where systems often run critical workloads like web servers, file shares, or internal apps, segmentation becomes even more important. Let's say your web server gets compromised. If it's segmented properly, the attacker won't be able to pivot into your database or internal admin tools. Tools like IP tables and NF tables let you define strict traffic rules, like who can talk to whom and under what conditions. This turns your Linux environment into a set of well-guarded vaults instead of one big open floor plan. All right, so how do you actually do segmentation in Linux? It starts with breaking up traffic using VLANs or subnets. You can create isolated zones for different services, maybe one for your public web server, one for your internal apps, and one for your database. Then you lock those zones down with firewall rules that only allow necessary communication. Tools like bridge utils, NMCLI, or even container network interfaces give you full control. And if you're in a virtual or cloud setup, segmentation is even easier to automate and scale. Segmentation isn't just about blocking threats. It's a powerhouse strategy that brings multiple advantages. Not only does it strengthen security, but it also helps with network performance and regulatory compliance. By breaking the network into controlled zones, you reduce congestion and make traffic flow more efficient. But the real win? Limiting lateral movement. If an attacker does breach one area, segmentation acts like a firebreak, making it much harder for them to reach high-value systems like your databases or admin panels. To make segmentation work well, follow a few best practices. First, enforce least privilege access. Only allow traffic between segments when it's absolutely necessary. Then monitor communication between those segments, watching for anything unusual. Tools like AuditD or centralized logging with syslog can help you keep an eye on what's happening. And don't forget, networks evolve. Systems get added, services change, and what worked 6 months ago might not work today. That's why regular audits are key. You've got to check your segmentation rules and architecture on a routine basis to make sure they're still doing their job. VPNs are your go-to for protecting data when it's on the move. Picture this. You're connecting to your company's internal Linux server from a coffee shop Wi-Fi. Without a VPN, that traffic is vulnerable to snooping. But with a VPN, your traffic gets encrypted and routed through a secure server. It's like sending your data through a private tunnel while everyone else is out in the open. In cybersecurity, VPNs are crucial for secure remote access, safe communications, and protecting against man-in-the-middle attacks. So why exactly should you be using a VPN in a Linux environment? Let's break it down. First, there's encryption. When you're connected through a VPN, all your traffic, whether it's web browsing, file transfers, or SSH sessions, is wrapped in an encrypted tunnel. That means even if someone's monitoring the network, they can't see what data you're sending or receiving. This is critical if you're using public Wi-Fi or working remotely. You're essentially making your data invisible to attackers. Second, VPNs mask your IP address. That's huge for privacy. Instead of your real IP being exposed, websites and services only see the IP of the VPN server. This helps protect your identity, hides your location, and reduces your exposure to targeted attacks or geo-based tracking. It's like putting on a digital cloak. Third, VPNs give you a secure path through censored or geo-restricted environments. If you're in a region with tight internet controls or trying to access a service restricted by location, a VPN can route you through a server in a different country, opening access while still encrypting everything. And here's a bonus. Linux users often manage sensitive services like web servers or internal dashboards. With a VPN, you can lock those services behind the VPN tunnel, only allowing access if the connection is made through the encrypted link. That adds another powerful layer of protection against brute force attacks or unauthorized access. So whether you're a sysadmin, developer, or just a privacy-minded user, using a VPN in Linux isn't just about convenience. It's about keeping your communications secure, your data private, and your systems defended against a growing list of threats. In the Linux world, you've got some heavy-hitter VPN tools. OpenVPN is highly customizable, great for fine-tuning your setup with certificates, TLS encryption, and advanced routing. WireGuard is the new kid on the block. Lighter, faster, and easier to audit. StrongSwan supports IPsec if you need compatibility with enterprise systems. These tools integrate with Linux services like systemd, Network Manager, or CLI scripts, making them super flexible for everything from personal setups to enterprise deployments. Here's what it looks like in action. To set up OpenVPN, you install it with a single command, then you run it using a config file that contains all the key details: server address, port, protocol, and encryption settings. You can authenticate users with certificates, shared keys, or login credentials. This flexibility means you can tailor your VPN for performance or for maximum security, whichever your environment demands. Wireless networks are everywhere now. Offices, campuses, coffee shops, and Linux systems often sit at the heart of these setups. Whether acting as access points, routers, or even intrusion detection systems, Linux plays a key role in managing wireless security. The catch? Wireless communication naturally broadcasts data through the air, and that makes it an easy target for attackers. If your wireless setup isn't properly secured, it's like leaving your front door wide open. Sensitive data like usernames, passwords, and even business-critical traffic could be intercepted. In cybersecurity, wireless is often considered the weakest link, especially when misconfigured. That's why encryption protocols like WPA3 are so important. They ensure data is encrypted in transit, which helps stop eavesdropping. Linux admins can fine-tune these settings using tools like hostapd for access point control or WPA supplicant for client security. And beyond just encrypting traffic, wireless devices need strong authentication and monitoring. A Linux server running tools like aircrack-ng or Kismet can monitor for rogue access points, unusual activity, or unauthorized clients trying to connect. Basically, if you're serious about cybersecurity in a Linux environment, wireless protection can't be an afterthought. It's got to be part of your overall defense strategy. When it comes to wireless security, the threats are real and growing fast, especially in environments where Linux handles routing or network services. Let's start with eavesdropping. If Wi-Fi traffic isn't encrypted, attackers can literally sit in the same room or even across the street and capture all that data. It's called packet sniffing, and tools like Wireshark or TCP dump make it easy to pull out usernames, emails, and more. Then we have rogue access points. These are fake Wi-Fi networks set up by attackers that look legitimate, like company-guessed Wi-Fi, but are actually traps. When users connect, all their traffic is funneled through the attacker system. Even worse are evil twin attacks, where the attacker clones your real access points, SSID, and MAC address, fooling devices into connecting automatically. And don't forget weak encryption. Protocols like WEP or WPA can be cracked in minutes using tools like aircrack-ng. Once that's done, an attacker can join your network and start scanning for vulnerable systems or services. To fight back, Linux users need to enforce strong encryption like WPA3, disable SSID broadcasting if possible, and regularly monitor for unauthorized devices. Adding MAC filtering, rotating credentials, and running automated scans with tools like AirGeddon can also help keep wireless networks locked down. When it comes to securing wireless networks on Linux, you're not just picking the right encryption protocol, you're also using the right tools to configure and manage those connections securely. Let's go over four of the most important ones: NMCLI, IWconfig, IW, and WPA Rocker Supplicant. First up is NMCLI. This is the command line interface for Network Manager. It's powerful, especially when you need to automate or remotely manage wireless settings. You can scan networks, connect to secure Wi-Fi, and even control VPNs, all from the terminal. In cybersecurity terms, NMCLI helps enforce secure defaults, like only connecting to trusted SSIDs or requiring WPA2 or WPA3 encryption. Next is IWconfig. This one's a bit older, but it's still handy for quick checks and basic wireless settings. You can view things like signal strength or link quality and set parameters like SSID or channel. It's mostly used for legacy systems or troubleshooting, but it can still help you confirm whether your wireless interfaces are using the right configurations. Then there's IW. Think of this as the more modern and detailed replacement for IWconfig. It gives you deep control over wireless interfaces, scanning networks, checking supported encryption types, and adjusting things like frequency or power levels. From a security standpoint, IW lets you verify exactly what kind of encryption a network is using, which helps you avoid accidentally connecting to unsecured or spoofed access points. And finally, we have WPA Supplicant. This is the real workhorse behind the scenes. It handles the authentication and encryption handshake when your device connects to a WPA secured wireless network. In a cybersecurity context, this is where you make sure you're using strong encryption, like WPA2-Enterprise or WPA3, and where certificate-based authentication can be enforced. You can configure WPA Supplicant to reject weak protocols and only trust properly signed certs, which is critical in enterprise or sensitive environments. So when you're securing wireless on Linux, it's not just about picking the right password, it's about using these tools together to ensure the system only connects securely, authenticates properly, and avoids weak or rogue networks. When we talk about wireless security, especially in a Linux environment, we're not just locking down your Wi-Fi with a password. We're thinking holistically about how to keep that network airtight from attackers. First off, use strong encryption. Always forget WEP and even WPA2 personal if you're in a business or sensitive setting. WPA3 is the current gold standard. If you're managing the access point with Linux tools like HostAPD, make sure it's configured to use WPA3 or at least WPA2-Enterprise. These protocols offer stronger encryption and protect against offline attacks. Next, think about controlling who connects. Set up MAC address filtering, hidden SSIDs, or even better, use certificate-based authentication with Radius and WPA Supplicant. This ensures that only verified devices can even attempt to connect. Another key step is monitoring your network. Linux has great tools like Kismet, AeroDump NG, and Wireshark that let you sniff traffic and detect unauthorized access points or suspicious activity. For example, if someone sets up a rogue AP or clones your SSID to pull off an evil twin attack, these tools can help you catch it before any real damage is done. And don't forget interface security. Disable Wi-Fi radios when they're not needed, especially on critical servers. Keep your wireless drivers and firmware updated, and use IP tables or NFT tables to restrict what wireless clients can access once they're on the network. At the end of the day, wireless convenience comes with real security trade-offs. But with Linux, you've got all the tools to build a smart, secure wireless setup, one that protects your users, your data, and your entire network from the threats that love to lurk in open air. Let's talk about proxy servers, what they are and why they matter, especially when it comes to cybersecurity. At its core, a proxy server is kind of like a middleman between your device and the internet. Instead of sending your web request straight to a website, your request goes to the proxy first. The proxy then forwards that request to the site, gets the response, and sends it back to you. So to the outside world, it looks like the request came from the proxy, not from your actual device. Why is that useful? Well, first, it adds a layer of privacy. Your IP address is hidden behind the proxy, which helps keep your location and identity private. That's huge for protecting user anonymity. Second, proxies give you control over traffic. In corporate or educational environments, admins use them to block certain sites, monitor usage, or cache frequently visited content to speed things up. You might hear about tools like Squid or Provoxy being used for this kind of setup in Linux. From a security standpoint, proxies can also act as filters, screening out malicious sites, blocking sketchy requests, or even stopping certain file types from coming through. And when you combine a proxy with HTTPS filtering, you can detect and stop threats before they reach the internal network. So to sum it up, a proxy server is more than just a relay. It's a smart checkpoint that boosts privacy, performance, and protection in any network, especially in secure Linux environments. A forward proxy protects clients, great for content filtering or hiding internal IPs. A reverse proxy shields backend servers, used often with web apps. Transparent proxies operate invisibly and can enforce security policies without the client even knowing. SOX proxies are more flexible and can handle all sorts of traffic, perfect for anonymizing and routing securely. Each one offers a unique way to control and protect data flow. Linux offers some excellent proxy tools. Squid is perfect for caching and filtering, used by schools and companies to control traffic. InionX, aside from being a web server, works great as a reverse proxy for load balancing and DDoS protection. Provoxy adds privacy features like ad blocking and content filtering. And then there's Tor, which anonymizes your traffic through multiple relays, ideal for evading surveillance or protecting whistleblower communications. These tools are powerful when used correctly, but they also require careful configuration to avoid leaks or misroute. So, why would you want to use a proxy server for cybersecurity, especially in a Linux environment? Great question. Let's break it down. First off, proxies add a solid layer of protection between your internal systems and the outside world. Instead of your actual Linux server making a direct request to the internet, the proxy steps in and does it for you. That means your real IP address and system details stay hidden. Great for keeping a low profile and avoiding targeted attacks. Next, proxies help with traffic control. In Linux, tools like Squid and Nginx let you define rules for who can go where, when, and how. That's huge in a security context. You can block sketchy websites, restrict access based on user roles, and even inspect traffic for signs of malware or suspicious behavior. Another major win? Anonymity and privacy. If you're doing sensitive work, say penetration testing, OSINT research, or just browsing securely, proxies like Tor route your traffic through multiple relays. That makes it extremely difficult for anyone to trace your activity back to your Linux box. And then there's monitoring and logging. A proxy gives you visibility into network activity. You can track usage, detect policy violations, and catch data leaks early. In a business or enterprise setup, that's absolutely critical for both compliance and threat detection. So bottom line, in Linux, using proxy servers isn't just about browsing, it's about controlling, monitoring, and securing how your systems talk to the outside world. It's smart, it's flexible, and it's a key part of a strong cybersecurity strategy. To wrap things up, network segmentation helps you control and contain threats.